Welcome everyone. Today I'll be presenting my introduction to data science project on predictive analysis using real world sensor data. And mainly I will present in this presentation was abstract introduction, project objectives like data pre-processing and cleaning, and EDA explore the data analysis, feature engineering, and development and an evolution of a predictive model and conclusion. And my project abstract was to predict a pump broken. I mean, we have in my project I have a normal recovery broken these kind of operational status, and I have a 52 sensors to detect the predictive maintenance of the pump. So the introduction, the goal of this project is to use data from sensors on individual pumps to predict whether they work in normally recovery from the problem or a broken. This is important because it helps in planning maintenance before failure can be caused downtime or expensive damage after in industry. So the project objective is our objective were clean and prepare. Mean, I have to clean and prepare the sensor data, explore it to find patterns, engineer new features to help with the predictions, and finally build and test models that can predict the pump's status and data overview. In my data set, I have a 2000 I mean 2 lakhs 20,320 observations and 52 features, and each of the 53 features contribute timestamped readings, provide a multi-dimensional view of pump performance. And I've previously said that data points are categorically into three types: normal, recovering, broken. These are three target predictions, and the data is huge. I've trained for nearly 5 to 6 hours. It takes 5 to 6 hours for my model to train the and give a perfect output. And this is the my data use which I've used, and data pre-processing file. Firstly, I clean the data by removing unnecessary columns and filling in missing values. Then I made sure all data points were consistent and ready for analysis by adjusting for any ready outliers and standardizing the measurements. And I've done many uh, useful algorithms to do this data pre-processing. And this is a visualization of my code, and this is the EDA, exploratory data analysis. Uh, Now, in these I've shown sensor data trends. I mean, for every sensor there is a different type of color that indicates the wave which you have seen in the image. And the data is started from 2018 and April, and this is a correlation heat map. And this is daily average sensor readings of my sensors. And now I'm going to explain feature engineering. Uh, I then created a feature engineering from the data, likely rolling like averages and lag features, which helps in capturing trends and the history context of sensor readings, making a model more accurate and more perfect. Uh, Rolling status, lagging features, these make my data very much I mean better, because using these the data accuracy and clear better performance. You can see this after feature engineering. This is my output. By these the model getting easy for me, and the predictive model. I created new features from the data like for the predictive model. I've used three different types of models: large logistic regression, random forest, and SVM. Each model was trained and to understand patterns from data that indicates the pump status. To address these, I have used different techniques for or other output and other algorithms also. But these three are best comparatively other algorithms which I have used. The model were given better performance and for uh, I mean, I faced a little bit imbalanced class in logistic regression and random forest. From these two algorithms gives imbalanced um, in predictive, but SVM gives a better prediction for me. Uh, the all the prediction gives me a, good performance, and I've calculated all the models by evaluating using precision, recall, F1 score, and accuracy. By these components, I have evaluated the my model, which is best, and all models are achieved an accuracy of one, but SEM shows showing the best performance in handling imbalancing features. These results will, especially considering the imbalance matrix, the SVM was identified as the best performer and choose selected as the best performing model for predicting the operational status of individual firm. And this is my overall output for my project. You can see the everything which like precision, recall, F1 score, support, and accuracy, micro average, weighted average for every different algorithm. And in conclusion, this project shows that machine learning can efficiently predict pump failure before they happen, potentially save time and money on maintenance. Future work could explore more advanced and more models, include more data types for better performance. The findings for me on this project to underscore the potential of predictive maintenance of significant enhance operational efficiency and reduce downtime in industry settings. Looking forward, integrating more complex algorithms and expanding data source and further improve the predictive accuracy and reliable of my models, paving the way of smarter data-driven maintenance strategies in industrial applications. And this is I'll show the overall code of for my model. This is the my data which I have used in. First, I have removed unnamed 0, sensor 15, sensor 50 for this. In this sensor 15, sensor 50, we don't have a particular data, so I have removed. And this is my graphs. After feature engineering, this is my output. And this is my overall outputs of three models: precision, recalling, F1 score. And thank you. Thank you for listening this.